All right, so starting with this first problem, it's on the bottom left of page 4 of 3.2. First of all, what relationship do these two angles have?
Alternate.
They're alternate exterior. My iPad is not wanting to load. They're alternate exterior. What do you know about the measures of alternate exterior angles? They're congruent. I'm just going to give up on my laptop. Never mind, I got it. All right, so they're going to be congruent. So what are we going to do with 21x plus 6? Set it equal to 90, because that's what this angle is. So again, we did that because alternate exterior angles will be congruent. Subtract 6. 21x equals 84. Divide by 21. And x equals 4. In the second problem, what relationship do these two angles have? They're corresponding. And when you have corresponding angles on parallel lines, what do you know about their measures? Do you think they're? So they're congruent. They're in the same spot. They're going to be the same measure. So that means 11x minus 2 will equal 75. So add 2. 11x equals 77. Divide by 11 and x is 7. Perfect. The only one that is supplementary, there are 2 of them. Which ones are they? A linear pair and consecutive interior. Remember, consecutive interior would be inside and on the same side of the double lines. So, like this question on the last page. So we're on the last page. This should be page 5, right? All right, so what relationship do these two angles have?
Consecutive interior.
They're consecutive interior, which means that they are supplementary. So if they're consecutive interior and supplementary, am I going to set these two angles equal or add them up to 180? Add them up to 180. So x plus 109 plus x plus 89 equals 180. Combine some like terms. X plus x is 2x. And then 109 plus 89 is 198. Equals 180. Subtract 198. Two x equals negative 18. Divide by 2. Negative 9. Did it ask me for x? It did not. It asked me for the measure of the bolded angle. I believe it's still bolded on yours. Yep. So you'd plug it in. Negative 9 plus 89, which is 80 degrees. So can you have a negative x?
Yes.
Yes. Could you have a negative angle? No. You could always check by plugging it into the other. You would have negative 9 plus 109, which is 100. And they were supposed to be supplementary, and they are. You can put that away and take out 3.3. So yesterday, we learned if lines are parallel, then corresponding angles are congruent. Today, you're going to learn the opposite. So if corresponding angles are congruent, what could we conclude? There's parallel lines. That's the opposite. We're going to do that today. So starting with some terms. I didn't write it all out, but you saw it. Yesterday was if lines are parallel, then corresponding angles are congruent. Today we're going to talk about if corresponding angles are congruent, then your lines are parallel. We want to prove parallel lines. So before we do, what is a parallel line?
Two lines.
Line on the same plane that never intersect.
Yeah, they're coplanar and they never intersect. So lines that are coplanar and they never intersect. I believe it is the first blank on 3.3. Lines that are coplanar and never intersect. All right, and then the second word is transversal. What is a transversal? Yeah, a line that intersects two or more lines. A line that intersects two or more lines. And then it does say at different points. So, which of these lines is a transversal? It would be C. So we haven't been writing at different points, but the lines would, well, B is also, they're all one actually. So C is transversal with A and B. A touches B and C at two separate points. Technically all of them are. That's a bad example. Let's try this then. Is there a transversal?
No.
There is not. They all intersect at one point. There would be no transversal here. So that's all that means. But for the most part, we've been looking at transversal look like this. So you're going to take out one highlighter. We're going to talk about proving that lines are parallel. Just one highlighter for today will work. One highlighter will work. All right, so the first one is about corresponding angles. So this is what this will look like. Go ahead and write corresponding angles in the left box. Corresponding angles. Corresponding angles. So we could use corresponding angles to prove that lines are parallel, and here's how. So if two lines are cut by a transversal, so that corresponding angles are congruent. You'll fill in the blank. So that corresponding angles are congruent. Then the lines are parallel. So if any of these were congruent, then you would have enough to prove that J is parallel to K. So if angle 1 was the same measure, was congruent as angle 5, that is enough to prove they're parallel. Or if 2 were congruent to angle 6, that is enough to prove that they're parallel. 3 and 7 or 4 and 8. So here's what that would look like. Give me a number for angle 1.
50.
We'll do that for angle 2. So 50 degrees. It's saying if these were the same measure, this is enough to prove the lines are parallel. And it is because all of the relationships you learned yesterday, alternate interior angles would be congruent, right? What would angle 3 be? 50 degrees for more than one reason, but mainly 2 and 3 are vertical, right? So they would end up, alternate interior would end up being congruent. My alternate exterior would end up being congruent, right? And then all the remaining, what would 1, 4, 5, and 8, what would they measure? 130. So all of the properties would be true, and my lines would be parallel, simply if I saw that corresponding angles were congruent. So you're going to highlight the word corresponding angles. And then highlight the blank congruent. So if your corresponding angles are congruent, that is enough to prove lines are parallel. All right, the second, alternate exterior angles. So go ahead and write that in the box. Alternate exterior. So if two lines are cut by a transversal so that the alternate exterior angles are congruent, then the lines are parallel. So your blank is congruent. So if your alternate exterior angles are congruent, that is enough to prove that the lines are parallel. So again, you'll highlight alternate exterior, and then you'll highlight the word congruent. So if your alternate exterior are congruent, that is enough to prove that you're parallel. So if angle 1 were congruent to angle 8 in my picture, that is enough to prove J is parallel to K, and the same thing if 2 is congruent to 7. The third is alternate interior. If the alternate interior angles are congruent, then that is enough to prove that the lines are parallel. So if your alternate interior angles are congruent, that is enough to prove that your lines are parallel. So you can highlight alternate interior and then the word congruent. So if angle 3 is congruent to angle 6, that is enough to prove the lines are parallel. And then if angle 4 is congruent to angle 5, that is enough to prove that they are parallel. They last is about consecutive interior angles. What would you have to guess about their measures? They need to be supplementary. So if consecutive interior angles, which is the last theorem, if consecutive interior angles are supplementary, that is enough to prove that your lines are parallel. So if your consecutive interior angles are supplementary, that is enough to prove that the lines are parallel. So notice which two were not listed. So which two relationships?
Corresponding.
Well, corresponding was. That one was. Which one? Vertical and linear pair were not listed, and here's why. Let's look at alternate interior. These angles both touch. One touches line J, one touches line K, right? Alternate exterior. One touches line J, one touches line K. Corresponding. One touches line K, one touches line J. But with vertical, they're across from each other, right? Would I have any information about line K or this intersection down here? No. So vertical is not enough to prove that they're parallel because we just don't have enough information. And then a linear pair is the same idea. A linear pair, they're adjacent to each other. They only touch one of the lines. We would have no information about line K. So just remember that it's the 4 new properties. Those prove that lines are parallel. But vertical angles and linear pairs, they will not. So we're going to use this in the section below. This is just saying consecutive interior need to be supplementary. But decide whether there's enough information to prove that line P is parallel to line Q. If so, state the theorem you would use. Go ahead and highlight state the theorem, and I'll explain what I'm asking you to put. So instead of you memorizing the theorem names, what I am asking you to do is state the relationship and whether they were congruent or supplementary. That is all I'm asking. State the relationship and then whether they were congruent or supplementary, which is essentially what the theorem said in the first place. So, our first example, what does it mean when these angles have arcs? They're congruent. So first of all, is there a relationship between these two angles? Yes, they are. They are congruent, but they're corresponding. Are corresponding angles being congruent, is that enough to prove that lines are parallel? Yes. So here's where we're going to put yes. So it's asking, decide whether there's enough information. Yes. And the relationship is that they're corresponding. Relationship, corresponding angles, and they are congruent. So is there enough to prove the lines are parallel? Yes. And the corresponding angles are congruent. In the second question, what relationship do these two have? They don't have a relationship. So the second thing you need to figure out is, if these were parallel, would these angles actually be congruent? So let's put a number on this. We'll say 80 degrees. Okay. Would this angle down here be 80 degrees? It would not. The angle next to it would be 80, but what would this angle end up being? 100. Yeah. So this one is there enough information to prove the lines are parallel? No. We don't have to write anything else. It doesn't say explain why not. It just says if there is enough information, state the theorem. Please write no. find the value of x that makes m parallel to n. So if these lines were parallel, what relationship, first of all, would these two have? They're corresponding. So if the lines were parallel, what do we know about corresponding angles? They'd be congruent. So that means 3x plus 5 would equal 65. So we do still have to solve for x. Subtract 5. 3x equals 60. Divide by 3. And x is 20. So we're on the last page. It says find the value of x that makes line S parallel to line T. Explain your reasoning. Again, we're going to list the relationship and whether they are congruent or supplementary. So what relationship do these two angles have? They're alternate exterior. So you do need to write down their alternate exterior, which means if the lines were parallel, what do we know about alternate exterior angles? They're congruent. So essentially we're kind of answering this backwards. We just explained our reasoning. Now we need to solve. So if they're congruent, what do I do with these two? Set them equal. So 2 times x plus 10 will equal 3 times x minus 8. Distribute. We got 2x plus 20 equals 3x minus 24. Move my smaller x, which here is 2x. So 20 equals x minus 24. Last step, add 24. So x is 44. So you want both things boxed or circled, however you answer your problem. All right, and then our last example. Explain our reasoning. What relationship do these two angles have? They're consecutive interior. Remember, do not shorten the word consecutive, but you can shorten the word interior. And then what does that mean for their measures? They're supplementary. So there are two ways to solve this problem, and both would get you the correct answer. One of them is you can literally, they're consecutive, and they're supplementary, so you could just add them up. And what would they equal? 180. That is option 1. We combine like terms. What's minus 12 plus 120?
32.
It'd be minus, so it's 108. Subtract 108. Yeah, 4x equals 72. Divide by 4, and x is correct. So that's option 1. What is option 2? Might be a little shorter. What will this angle equal individually? 60. So how do we know it equals 60? Yeah, 180 minus 120. So then you would have 4x minus 12 equals 60. You would add 12. What's, 60 plus 12? So you'd end up with 72, and you'd end up with 4x, and you would still end up with x equals 18. So both ways are correct.